Hello, this is Mr. Precella, and I thought we're going to continue working on the test 1 review from our Math 13-14 class. We will pick up, we just finished, in the previous video we did 1 through 10. We're working with the quadratic formula. Here we're going to pick up at number 11. Let me write the problem down. It says solve the equation 5 over x squared minus 54 over x is equal to 11. Now this equation is not quadratic. It's not quadratic because it has variables in denominators. That's not a quadratic equation, but we can multiply through to eliminate those fractions. What could we multiply through so that we cancel out everything in both denominators? It's not just x. It needs to be more than just x. If we multiply this thing by x right there, would we cancel out both of those factors of x in the denominator? No. Repeated factors in denominator, you use the larger exponent for the least common denominator. So we're going to multiply by x squared, multiply by x squared, and multiply by x squared. So, this is going to work out nicely now. The x squares cancel, leaving us just a 5 minus, canceling x above and below. So you have a 54, and one of the x's remaining. And on the right hand side we have 11 times x squared. And let me pull this camera closer to me. There. Now this equation is quadratic. We need it set equal to 0. But remember, I like my leading coefficient to be positive, so I'm not going to get a 0 here. I'll get the 0 over here. I have an 11x squared. What else do I have here? A plus 54x, I agree. And move that over, it becomes a minus 5. And now we're ready to identify A, B, and C. A is equal to 11. B is equal to 54. And C is equal to -5, I agree. Recall the quadratic formula. I'll rewrite it again. I hope I have enough room here on this sheet of paper. So, what have we got here? The opposite of 54 is a -54, I agree. And then b squared, I better dig up my calculator, minus 4 times A times C. Sorry, I'm having to squeeze that in there. Can you see what I have? 54 squared, that's b squared, minus 4 times A, 11, times C, -5, all over. What's the denominator going to be? 2 times A, 2 times 11 gives me a denominator of 22. Where's my calculator? I need to clean off that stuff there. So we have, I'm punching in this stuff right here. I'm punching in the stuff under the radical. So I have a 54 squared minus 4 times 11 times a -5 equals, so we have negative 54 plus or minus the square root of, oh, I don't like that number, 3136, all divided by 22. 54 squared minus 4 times 11 times a negative 5. Okay. So, I don't believe that's a perfect square. Let's see. The square root of 3136. Oh, it is a 56. I mean, it is a perfect square. I was mistaken. Oh, this is great. Negative 54 plus or minus. Did y'all see that? The square root of 3136 is a perfect square of 56. Oh, that's making it nice. All over 22. Let me move that calculator out of the way. 3136, the square root of 3136 was 56. So we have two possibilities. Don't stop there. We can reduce further. Well, so x is equal to, let's break it into cases. Negative 54 plus 56 all over 22. Negative 54 plus 56, that's a positive 2 over 22, which is equal to 1 over 11. So there's the first answer, 1/11. And the second answer, negative 54 minus 56 all over 22. That's a negative 110 divided by 22. Oh, that works out nicely, doesn't it? To just a negative 5. Realize the only number that would have made these denominators equal 0 would be 0 itself. Did we get 0 as either of the answers here? No, we got 1/11 and negative 5. We got 1/11 and negative 5. So, we come over here and we patch in 1 over 11. And they want us to separate the answers using a comma, so get out of that by doing a right arrow, get out of the denominator, comma, negative 5. Number 12. Number 12. Let me write this problem down. 6x over x minus 9 is equal, oops, I miscopied the problem. Let's get rid of this piece of paper and maybe start all over. Number 12. 6x over x minus 6 is equal to 9 plus the fraction 7x squared over x minus 6. Okay. So, when I look at this equation, I see two fractions. They both have the same denominator. What number would be unacceptable? Just for the record, what number would give us undefined results? But the fraction, you don't want the denominator to be what? 0. You don't want that denominator to be 0, so x had better not equal 6. If we get anything else, that's fine. But if we get 6, we're going to have to discard it. We're going to multiply through by x minus 6 to cancel out every one of those fractions, or both of those fractions. Realize we have 3 terms. That single fraction is a term. How many terms do we have on the right? We have 2, the 9 and the single fraction. So we're going to have to be multiplying by x minus 6 all the way across. Multiply by x minus 6, multiply by x minus 6. The x minus 6's cancel, leaving us just a 6x. We have a 9 times x minus 6. Distribute that 9. What's that going to give us? A 9x, I agree, and what else? 9 times negative 6, a minus 54. This last product, what's going to happen? The x minus 6's cancel, leaving us just a 7x squared. And we need this equation set equal to 0, so why don't we move the 6x over? We have a 7x squared, 9x minus 6x, that gives me a plus 3x, and what else? A minus 54. And this is quadratic. We used the quadratic formula in the previous problem, so okay, I'm just checking. My camera was frozen. Hopefully, okay, it seems to be working okay. But so let's see. I believe this thing's going to be factorable. I think it's going to be factorable. So x squared, we could use a 1x times a 7x. And for 54, let's see, we could use a 1 times 54, 2 times 27, 3 times 18, 4, 6 times 9. Okay. Oh, what do we know about the signs? Last sign's a minus, so we need one of each sign. I'm going to go, I see it. Do y'all see it? How about a plus 3 and a minus 18? If you check, the outer product is a negative 18x. Here I am checking. First is obviously 7x squared. So the outer is a negative 18x. The inner is a positive 21x. The last is a negative 54. Do the outer and inner combine together to give you that middle? I think they do. Set each factor equal to 0. Set x plus 3 equal to 0 to give us x equals negative 3. Set 7x minus 18 equal to 0 to give us 7x equals 18, so x equals 18 over 7. The only number we said that would be unacceptable is 6, so these two answers are both acceptable solutions. So we have a negative 3, and we have the fraction 18 over 7. We have a negative 3, comma, 18 over 7. Oh, number 13. Let me write this down. Oh, it's a square root equation. The square root of 3x minus x plus 6 is equal to 0. With a square root equation or any sort of radical equation, you have to isolate a radical before you start raising both sides of an equation to a power. The only radical we have is that square root of 3x. So we'll isolate that by moving over these terms. That'll give us the square root of 3x is equal to x, and what have we got here? A minus 6. And then we square both sides. Square, square. The square root of 3x squared is just a 3x. What are we going to do here to square x minus 6? It's not just x squared minus 6x. Minus 6 squared. What are we going to have to do? That's right. You're going to have to write it twice and FOIL it out. X minus 6 times x minus 6. First, outer, inner, last, negative 6 times negative 6 gives us a positive 36. I get this set equal to 0. We have an x squared. Negative 6x minus 6x is negative 12x. Minus 3x. Negative 12x minus 3x. That's a negative 15x. And what else do we have? A positive 36. So this is a simple trinomial. I think it's factorable. If it weren't factorable, that means the solution would have a square root in it. And remember, we're going to have to check our answer. We're going to have to check our answer, and if this thing isn't factorable and you got an irrational number, it is going to become a real mess checking your answer. That's why I think it's factorable. X squared, well, that's an x and an x. Last sign's a plus. This is the nice situation. Last sign's a plus. You have two of the first signs, minus and minus. Up here, the last sign was a minus, so you had to play around and figure out where did the plus go and where did the minus go. But here, last sign's a plus. You have two of those first signs. And then for 36, 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. With a simple trinomial, you choose the pair. In this case, you need the pair that adds together to give you 15. Adds together to give you 15. Only one of these things is going to add together to give you that 15. Negative 3 plus negative 12 will give negative 15. So we have a minus 3 and a minus 12. I'll leave you to FOIL that out to verify that it gives you back x squared minus 15x plus 36. Set each factor equal to 0 to give us x equals a positive 3. Here, x equals a positive 12. But we have to check our work. So, going back to the equation containing the fraction, the radical, the square root of 3x minus x plus 6 is equal to 0. Plug in 3. 3 times 3 is 9. So you have the square root of 9 minus 3 plus 6 is 0. The square root of 9 is 3. 3 minus 3 plus 6 equals 0. True or false? False. So cross out x equals 3. If I were a gambling man, I would say that 12 has to work. But let's see. Plug in 12. The square root of 3x minus x plus 6 is equal to 0. 3 times 12. That's a 36, so you have the square root of 36 minus 12 plus 6. Will that equal 0? That's a question mark. 6 minus 12 is a negative 6 plus 6. Does that equal 0? Yes, it does. So 12 checks. 3 didn't check, but 12 checks. So we go over to my lab and we type in 12. Any questions there? But square root equations, anytime you raise both sides of an equation to an even power, that's when you have to check your work. And what's number 14? Oh, let's do that. I know we're running out of time, but number 14, you may think it looks awful, but it's actually pretty straightforward. Once you remember what they mean by an exponent of 1/3. Two x plus 6 to the 1/3 minus 7x minus 1 to the 1/3 is equal to 0. Okay, there. Remember, a 1/3 exponent is the same thing as a cube root. That's right. So you really have the cube root of 2x plus 6 minus the cube root of 7x minus 1 is equal to 0. And this is nice. We're not even going to have to check our answers at the end because this is a cube root. So you're raising both sides to the power 3. 3 is an odd number. You only have to check your solutions if you raise both sides to an even power. Remember, it's those even powers that take negative quantities and change them to positive quantities. That's why you may wind up with an extraneous solution like we did on number 13. But here, we need to isolate a radical. I'm going to try to isolate this radical, but when I do, I think we'll isolate that one also. So we'll have the cube root of 2x plus 6 is equal to the cube root of 7x minus 1. And then we can cube both sides. Cubing the cube root, we just have 2x plus 6. Cubing that cube root, we have a 7x minus 1. This isn't even quadratic, it's linear. We'll combine our x terms. 7x minus 2x gives me a 5x. I move that minus 1 over by adding 1. 6 plus 1 gives me a 7. Divide both sides by 5 to give me x equals 7/5. Notice I don't have to check my answers. I'm just going to go directly to my lab. We raised both sides. It was an odd power. Raising both sides of an equation to an odd power guarantees equivalence. It's when you have to use an even exponent that you have to check your work. So, here, our answer is 7/5. Any questions there? Any questions? Remember, a 1/3 exponent is the same thing as a cube root. And once you realize that, the rest of it falls out very quickly. I think we'll stop here for today because the next problem is a cut point problem, and that's a good place to stop. Okay, so we'll stop there for today, and we'll pick up here tomorrow. Okay, bye-bye.